Hello students. In my previous video I have already explained how the basic Gauss elimination method works. Today we will take an example and try to explain that how we can get the values of the unknowns from these equations. Now let us take an example like solve the following 3x3 system using the basic Gauss elimination method. So we are given with three equations and we have to get the values of three unknowns. Our unknowns are variable x1, x2 and x3. So the given equations are 3x1 plus 6x2 plus x3 is equal to 16, and our second equation is 2x1 plus 4x2 plus 3x3 is equal to 13. Third equation is 3x1 plus 3x2 plus 2x3 is equal to 9. So if you remember that in the basic Gauss elimination method, the first step is to eliminate the x1 from the second equation onwards, and then in the second step what we try to do is we try to eliminate the value of or the x2 variable from the third equation onwards. So the first step how we are going to do is like, first of all we will eliminate the x1 from the second equation and we will eliminate the x1 from the third equation. So the first step is to triangularize it. So as you see here, I have given this equation as number 1 equation, and I have given this marked the second equation as equation number 2, and I have marked the third equation as equation number 3. So the first thing is that we have to do something so that we can subtract or we can eliminate this 2x1 from the second equation. So we will have to subtract this equation, second equation, pivot element times by equation 1. So what is a pivot element? So somehow we have to make the coefficient of this value in a way when we will subtract this equation from this equation, the values in this term will be as 0x1. So it is only possible, first we try to make this as x1. So we will divide the whole equation, this whole equation by 3. So this will be equivalent to x1, and then we will try to make the values or the coefficient of x1 as 2x1, so that when we will subtract this from this it will be equivalent to 0. That means we will divide this equation, this whole equation by 3, and we will multiply it by 2. When we will divide this whole equation by 3 and we will multiply it by 2, the value here will come as 2x1, and when we will subtract this from this it will be equivalent to 0. So that's the pivot element mean. So that's what I am doing in my step first. So I am subtracting equation 2 this pivot element times. So my pivot element here is becoming 2 by 3. 2 by 3. See, when I will multiply this whole by 2 by 3, 3 and 3 will get cancelled. This will be equivalent to 2x1. So 2x1 and 2x1 are equal. So when I will subtract them, it will be equivalent to 0. So that's what I am doing. I am subtracting equation 2 pivot element times 2 by 3 by equation 1. By this equation, by equation 1, we get what we get. We get 2 minus this 2 minus 3 multiplied by 2 divided by 3. 2 divided by 3 is my pivot element, and the value will be x1, plus I have to subtract this from this. So I am taking 4 minus this will be equivalent to, I have to multiply it pivot element times. So it will be 2 divided by 3 multiplied by 6 x2 plus 3. I have to subtract it from this, but pivot element times, so it will be equivalent to 3 minus 2 divided by 3. Here my coefficient of x3 is 1, so it will be equal to multiplied by 1. It is x3. So that will be equivalent to 13 minus 2 divided by 3, 16. So when I will solve it, this and this will get cancels. 2 minus 2 is equal to 0, so it is 0x1. So here also this will be equivalent to 0x2. This term will be equivalent to 4. 4 minus 4 will be equivalent to 0. So this term will also tend to 0x2 plus When we will solve this, it will be 7 divided by 3 x3, that is equivalent to, when we will solve this, it will be equal to 39 minus 32 divided by 3. So if we will further solve it, you see from this term and this term is equivalent to 0, so we are left with only one term on the left hand side. So the 3 and 3 will get cancelled, and so we will be left with 7x3 is equal to 7. So therefore this equation, the second equation, is now equivalent to 7x3 is equal to 7, this second equation. Although we were trying to eliminate the x1 value from the second equation, but it has also eliminated the x2 value. Somehow you get a set of equations in a sense where more than one value gets eliminated. So then in our second step we have to follow the same thing. We have to again subtract this equation pivot element times from first equation, so that we will eliminate the x1 from the third equation. So again we will do the same thing. If you will see, we are subtracting equation third pivot element times, pivot element is 1 by 3. See here we have how we calculate the pivot element here, 1 by 3. So somehow we have to make this as x1, because here the coefficient of x1 is nothing, we don't have any constant before x1, so we have to make this somehow equivalent to x1. So how it will be equivalent to x1? It will be equivalent to x1 when we will divide the whole equation by 3. When we will divide the whole equation by 3, this will be equivalent to x1. So the term will be subtracted from this, and in this equation the x1 will be eliminated. So that's how I am saying that the pivot element here will be equivalent to 1 by 3. So we subtract equation third pivot element times 1 by 3 times by equation 1. So when we are doing it, it will be equivalent to 1 minus 1 divided by 3 multiplied by 3 x1 plus 3 minus 6 multiplied by 1 by 3 x2 plus 2 minus 1 by 3 x3, that will be equivalent to 9 minus 1 by 3 multiplied by 16. So when we solve it, see this term we are getting it as 0x1, this term we are getting it as x2, and this term we are getting it as plus 5 divided by 3 x3, so is equal to 27 minus 16 divided by 3. So when we further solve it, so this equation becomes as 0x1 plus 3x2 plus 5x3 is equal to 11. So this is basically now our third equation. So that means we have changed our second equation and we have changed our third equation. Basically we have eliminated the x1 value from, or the x1 term from, the second equation and the third equation. So our new set of an equation will be, our new set of equations are, the first equation, if you will see the first page, our first equation will remain as same. Our first equation will remain as same, 3x1 plus 6x2 plus x3 is equal to 16. This is our first equation. My second equation will be as, because in my third equation I have two variables, so I am writing the third equation first. The values of third equation I am writing first. So the second equation here will be equivalent to the values which I am getting for the third equation. It doesn't matter in what order you will write the equation. So I am writing it here because I have already eliminated two values from the third equation. So I am writing my third equation first, then I will write my second equation. So the third equation is 0x1 plus 3x2 plus 5x3 is equal to 11. That's what I get the values of the third equation after eliminating x1. So and my third equation is 0x1 0x1 0x2 plus 7x3 is equal to 7. So here I am writing the third. So I am getting the new set of equations as this. So if you will see, I don't have to move on further because I have already eliminated the x2 values from the third equation. So there is no need to move on to the step third. We will stop here and we will apply the backward substitution. In backward substitution, what we do is, we first of all try to get the value of x3 from the third equation. See, in our third equation, the value of x1 and the value of x2 is 0. We are only left with the x3. So we can easily get the value of x3 from this. So through backward substitution, we get 7x3 is equal to 7. That means our x3 is equal to 1. 7 divided by 7 is 1. So putting value of this x3 in equation 5. When I will put the value of x3 in equation 5, I will get the value of x2, because in my second equation x1 is 0. I have only two variables. If I will assign the value of one variable, I can easily get the second value. So putting value of x3 in equation 5, we get 0x1 plus 3x2 plus 5, and I am putting the value of x3 here, so it is equivalent to 11. When I will solve it, it will be equivalent to 2. Now I got the value of x2 as well as x3, so I will put these values in the first equation, because my first equation is in 3 variables. So when I will put the values of x2 and x3 in my first equation, I can easily get the value of x1. So same thing I am applying here. I am putting the values of x2 and x3 here. X2 in first equation, so my first equation is 3x1 plus 6. The value of x2 is 2 plus 1, that is equal to 16. When I will solve it, I will get the values of x1. So my value of x1 is equal to 1, the value of x2 is equal to 2, and the value of x3 is equal to 1. So the method is very simple. What we are trying to do is, first we are applying the triangularization process, and then we are applying the back substitution to get the values of x1, x2 and x3. So this is how we solve the set of linear equation using the basic Gauss elimination method. Thank you.